It's just amazing to me how this comes out of focus and how the camera head moves in between videos. Hi everyone, this is Volumes, Day 4. I know, and yet there's still more to learn after Volumes. And so I think that this is assignment 38. Hopefully, you are in class and you are experiencing calculus through the cutting of cakes. But I fear that that's not going to be the case this year. I would also have used this time to introduce the project to you. And that would pretty much take up all the class time aside from in addition to cakes and project. Yeah, we would also maybe take some homework questions because the only way you're going to get to know how to do this stuff is by getting you to do this stuff. But instead, I have planned for you a review of sorts. We're going to take another region. Today's region is going to be the area between y equals x and y equals x squared. And I really think we should just focus on the setups here. One of the upcoming worksheets, which is also, a heavier review of this stuff, I made sure to put all the answers for you so that you could check your work. And I think in addition to sort of reviewing with these problems, with this region through a variety of rotations for disks, washers, and shells, we should also do some footprints, but I kind of want to also do this thing called It's Time to Be Clear About This. And, depending on how things go, I'll either push that to tomorrow or get it into today's video. But really, certainly by tomorrow, you should be comfortable with the questions on that one. And, if you're not, that means I think you need to ask more questions. Maybe watch these videos again, but I actually think it's ask more questions. Okay, so here's our region. Y equals x, y equals x squared. We've got 1, 1 here. This is our region. All right, so what do we want to do with this region? Well, and the way I'd like to do this is with each of these different problems, I'd like to do both when we're doing disks and washers, to do both the setup for the shell version of the problem and for the washer or disk version of the problem. But before we do that rotational stuff, I'd like to, do square and do semicircle with this. And let's do those perpendicular to the x-axis, parallel to the x-axis. No, we don't expect them to be the same. Same region, different volumes. Okay. So let's take a look at that. Let's start then. First problem, I want to draw the cross sections are squares perpendicular to the x-axis. Okay, and all I want is the setup. I want the setup for finding the volume of the solid whose cross sections are squares perpendicular to the x-axis. All right. So please pause, give this a try, come back when you're done. Hey, welcome back. Can't wait. So this is my square. And notice that the thickness of that square would be measured here on the x-axis. So this is a dx cross-section that I'm doing. Okay. I also know that I'm integrating area, and for a square, that's side squared. I'm integrating from x equals 0 to x equals 1. I just need to know what to find the side is. Well, the side is this distance. S is top minus bottom. Top minus bottom. And I need s squared. So integral from 0 to 1 of x minus x squared dx. That's going to be my setup. Okay. Now, what if instead we said cross sections are squares perpendicular to the y-axis? How does that change things? Our squares go this way now. Yeah, that's way too hard. Okay, pause the video, give that a try. Hey, welcome back. Again, we're doing area, which is side squared. This time we're going from here to here, not here to here. Here to here, 0 to 1. The thickness is measured here on the y-axis. And so I really want everything to be in terms of y's, not x's. So what do I know about the side? Well, right minus left gives me that side. Now, this right thing looks like y equals x squared, but, I need x equals. So x equals square root of y. And here, well, this is y equals x, so x is going to equal y. So right minus left. So we've got the integral from 0 to 1 of right minus left. Don't forget to square that, right? Because we want area. Area is side squared. This is just side. I need side squared dy. Okay, that's those. Now, what if we take that same region all through this video, same region, and this time, let's build semicircles on it. Okay. Here's our region. And we want cross sections that are perpendicular to the x-axis. Ooh, and I'm glad you asked. I want to say that the diameter that this distance is the diameter. I don't want circles. I want perpendicular to the x-axis are diameters of a semicircle. Yeah, there's a lot of things in that problem. That's been chosen specifically based on experience. Pause the video and go give it a try. Okay, so the thickness is measured here on the dx. Okay, so I've got dx integral. Pi r squared? No, that's a whole circle, and we only have half a circle. We want a 2 there. So, what's my radius? Well, I don't know. I see that the diameter is top minus bottom. And diameter is 2 times the radius. Well, if I want radius, I need to divide by 2. Y equals x minus x squared over 2. You, of course, might want that like this as your radius. Well, I'm just doing the setup, so 0 to 1, pi over 2. Here's our radius. X minus x squared over 2 squared. We need radius squared. Okay, so I mumbled something about a lot of 2's. There's this 2 because we're talking about a semicircle. There's this 2 because we're talking about a diameter, and radius is half of that diameter. And watch out, the squaring squares that number. So this is going to be 4 times 2, which is 8. And I can bring that pi over 8 constant out. X minus x squared squared dx. Okay, and we're going from 0 to 1. Fabulous. Okay. How about we still have diameters, but this time a circle. And so what changes then? Pause the video. Modify the last answer. Show me what it looks like. Hey, welcome back. So we were integrating the area of a circle, not a semicircle. We still have dx. We know the diameter is still top minus bottom, and we're still looking for radius. And we still need to square the radius. So we're going to have from 0 to 1 pi x minus x squared over 2 squared dx. So this answer should be double or half of the other one. Well, the other one was semicircles and this one is circles, and so I would expect this answer to be twice as big as the last one. All right, so footprints. Footprints. They show up a whole bunch on the AP exam year after year, but so do washers and shells. So we're going to do a bunch of problems, and remember, I'd like to do the setups for each of these problems, both as shell and as washer setups. Not interested in going through and evaluating them. You certainly can, and you'll certainly have to do that on the exam and on a test, but really, that's not usually the hard part. So let's take a look at the hard part. We're still talking about this region, Earth. What? This is our region. And what are we doing? Well, what if I wanted to rotate about the y-axis? Okay, and I would like you to do two setups. I want you to do disc or washer setup, and I want you to do the shell setup. Okay, pause the video, give it a try. We're rotating about the y-axis. Hey everyone, welcome back. So if I have this region and I'm rotating around the y-axis, there is a gap between the region and the axis of rotation. So I know that I'm going to have a washer. Little r is this x value. It's the x value that goes with that line. So that's the line y equals x. Big R is this x value. It's the x value that goes with y equals x squared. And so x is square root of y. So big R is square root of y. So my setup then here is going to be pi, don't lose the pi. We're integrating from 0 to 1 on this dy integral. And we need big R squared minus little r squared. And of course, you could tidy this up to be y minus y squared. Again, that's not going to be hard to integrate. Now, what about doing that same problem? But this time, we're doing shells. And so with shells, I want to draw something that is parallel to the axis of rotation, and we're going around the y-axis. So there's my shell. Now, this ordered pair, x, y, well, that is x, and that's my radius. So r equals x. And the height, well, the height is top minus bottom. So I'm going to have x minus x squared. And so we get the integral from 0 to 1, because we're integrating this way. We have 2 pi x minus x squared dx. Okay, so there's are set up for each. Now, unlike the footprints, where the dx footprint and the dy footprint produce different volumes because, well, they make different shapes, these are going to make the same shape. So these volumes should be the same. So one way you can check your work is to do the other method and make sure you get the same answer both times. You might want to try that. Okay, so that was about the x-axis. I'm sorry, about the y-axis. Now let's go about the x-axis. Okay, please go about the x-axis. Yep, same region. Taking this region and spinning it around the x-axis. Excellent. Again, I want both. I want disk and washer, and I want shell. Okay. Come back when you're done. Hey, welcome back, everyone. So if I'm doing disk and washer here, and we're going about the x-axis, and draw something that is perpendicular to that x-axis. Perpendicular. Okay, and I notice I'm getting a washer because there's a gap between the region that I'm rotating and the axis of rotation. So my little r is this y value. Little r is the y value that goes with x squared. This big radius is also a y value, but it's the y value that goes to y equals x. So my setup here, 0 to 1, this is a dx integral. I've got pi big R squared minus little r squared. Done. I mean, pi 0 to 1 x squared minus x to the 4th dx. There you go. What about shell? Well, shell, I'm going to draw something that is parallel to the axis of rotation, and I'm going to make the axis of rotation the center for these circles I draw. So we know this ordered pair is xy, and that's y. Y is my radius. Okay, what about the height? Here's the height of my shell. And my height comes from right minus left. H equals, the right is this x value, and the left is this x value. Well, that's the x from x equals y. But this distance, this is the x that goes with y equals x squared. So that must be square root of y. So I have square root of y minus y as the height. I know you want me to say that again. Okay, there we go. Got this, and you've got this is y equals x, and this is x comma x squared. Right? But since we have this dy integral, knowing that this x value, yeah, that's nice and all, but I really need everything in terms of y. So this, well, y equals x squared, but I know that this is simply x, so I have to take the square root here, and so square root of y equals x. Yeah, and that height then is this x value minus this x value. Right? This is the x that goes with y equals x, and this is the x that goes with y equals x squared. But I need the x there, right? To do right minus left, it's x value minus x value to find that. And so I have to take this equation and solve it. So it says x equals, and that's why I get the square root of y. So that's why height is right minus left, and the radius was y. So my setup then, 2 pi integral 0 to 1 of r, rh is going to be y times square root of y minus y dy. All right. Yeah, lots of thinking. If you're struggling right now, you might want to just go back and play those last 2 videos or send some questions to the GroupMe. I've got 6 more. Yeah, 6 more. Okay, maybe we'll do that. We should know this by now in the next video. Okay, how about we want to rotate about y equals 1. That's my axis of rotation for this region. And again, it's washers and shells. So, show me what that looks like. Rotating this region around that axis. Hey everyone, welcome back. So, we've got this region. I don't want to do it that way. That, and here. And we're taking this region and we're spinning this region around the line y equals 1. Okay? Well, I know with a disc or washer, I'm supposed to draw something perpendicular to the axis of rotation. And at each end, I draw a circle. Now, this is little r. Little r is not the y value for this line. Right? We're talking about this now. That's little r. That's the y value. And this is 1. So little r is 1 minus y. But we know that this is a dx washer. And because of that, I have to get rid of that y and put x in its place. By x instead of x squared, this line is y equals x here. When I go to talk about big R, it goes all the way to here. Big R goes to here. This is y, this is big R, this is 1. And so big R is going to be 1 minus y, but the y value here is for this bottom part, y equals x squared. So 1 minus x squared. So then, integral pi big R 1 minus x squared minus little r 1 minus x squared dx, and we're going from 0 to 1. You're only ever integrating the region. That'll be important in a few minutes. Okay, now how to go with shells. Rotating here, and draw something parallel to the axis of rotation. So it looks like height is right minus left. Okay, and that's definitely going to be a dy. I need my radius. This distance is y. This distance is r, and this is 1. So r equals 1 minus y. Height's a little trickier though. So this is the x value for y equals x squared. So that x value we said was square root of y. And this is the x value for y equals x. And so now I know my height in terms of y's. So this is going to be the integral 2 pi 0 to 1 of 1 minus y times y minus square root of y dy. Okay. what do we rotate around next? Well, I think we should rotate around y equals 2. Y equals 2. How does that change the problem to rotate around y equals 2? There's my region. That's 1, 1. And we're rotating around y equals 2. Again, I'd like disk and washer or shell. Okay, give it a try. Show me what you got. Hey, welcome. So this region is definitely not up against this axis of rotation, so I know I'm having a washer. I'm going to draw something perpendicular to the axis of rotation. And I get this big washer. This is my radius, my little r. This is y. This is 2. 2. This is 2. So I could say that little r is 2 minus y. And since this is a dx washer, I need to get rid of that and replace it with some x stuff. But is this the y for the parabola, or is this the y for the linear equation? Well, we're doing little r, and little r is the smaller bit, and that is meeting the linear equation. So this is 2 minus x. I also need big R here. That's big R now goes from here to here. And again, that's not y. This distance is y. This distance is 1. 2. This distance is 2, and so our big radius must be 2 minus the y value, but it's the y value for the parabola, 2 minus x squared. So my setup for this, pi 0 to 1, 0 to 1, you're only going from 0 to 1 with these x's. Okay, and we've got big R squared minus little r squared. Don't lose that. A lot of kids do. And when a lot of kids lose that, look what they got. 2 minus x squared, 2 minus x squared, 0. And that doesn't have a value of 0. Okay? All right. With shell. Okay, so if I'm thinking about this with shell, going back here, draw something parallel to the axis of rotation, and at each end, draw a circle whose center is the axis of rotation. Radius is this distance. This is y, this is 2. So radius is 2 minus y. Now the height of the shell, is right minus left. Right minus left. And, I'd be tempted to say that this is x squared minus x, except for the fact that this is a dy shell. So we need everything in terms of y's. Well, that's easy here, because on this line we know that y equals x. But over here, y is equal to x squared, and I know that this distance is the x value to that point. So I want to take that and solve it for x. X would be equal to the square root of y. And we want square root of y here. That's it. Okay, sorry. Okay, so the right function, or the right bounding curve, is this x amount. And the left is this x amount. but these need to be in terms of appropriate y's. Here, this left one is the line y equals x, so no worries. The right one is the x that goes to the parabola. So I take the parabola, I solve for x, and I see, aha, this x is equal to square root of y. So then my integral 2 pi 0 to 1, 2 minus y, square root of y minus y, dy. We're integrating from here to here. This is 1 because we're only integrating the region. The region stops at a y value of 1. We're rotating around y equals 2. Yeah, I agree. That's true. But, yeah. So, radius, height. I like it. Okay. It was around y equals 2. How about we rotate around some vertical things? So, how about we rotate about x equals 1? Rotating this region, and we're rotating it around x equals 1. Can you do those setups for me now, please? Pause the video, give it a try. Okay, so we're rotating around this x equals 1 vertical line. With discs and washers, I'm supposed to draw something that's perpendicular to the axis of rotation. So, at each end, I draw a circle whose center is the axis of rotation. I know that this is going to be a washer. It's a dy washer. Look how that horizontal will be measured over here on the y-axis. Okay, so this is dy, and I know I'm looking for a big R and a little r. Okay, this is little r. This is x, this is 1, and that's little r. So little r is 1 minus x. But it's a dy integral, so I'm not going to be able to use this x. Instead, I need something y-like, and it's the x and y relationship for the parabola. So if y equals x squared, then x equals square root of y. So little r is 1 minus square root of y. What about big R? Okay, so big R is that. That's big R. This is the x that goes with big R. This is 1. And so big R is 1 minus x to get that. Except that this x value doesn't go to the parabola. This x value goes with the linear equation. And so I get 1 minus y. So pi 0 to 1, 1 minus y squared minus 1 minus square root of y squared dy. Okay. I know, it's exciting, isn't it? So let's take a look at shells. See if there's a little more solace there. So let's have this region about there. And we want something that is parallel to the axis of rotation. Okay, I can see that the height is top minus bottom. I also see that this is a dx integral, so this y value minus this y value. And the radius here, well, that's the radius. That's x, and that's 1. So little r is 1 minus x. So this is going to be 2 pi, 0 to 1, 1 minus x, x minus x squared dx. All right. I think this is easier than that one. I know you don't. Maybe you do, but really, oh, God. What about, instead of about x equals 1, we do x equals 2. Why don't you pause the video and try both of those? Oh, and then we'll rotate around some negative numbers before we end for the day. Okay. Here's x equals 2. Here's the point 1. We want disks and washers, and rotate about that. So I'm going to draw something that is perpendicular to the axis of rotation. And there's my little r. Okay? This distance is x. This distance is 2. So little r equals 2 minus x. But this is going to be a dy. And this x goes to the parabola. So this is the same as that. Now, what about big R? Well, big R goes from here to here. Again, this distance is x. This distance is 2. And our radius is here. So big R equals 2 minus x. But in this situation, that x value goes to the linear equation. So we have 2 minus y. So we end up then with pi, so 1 of 2 minus y squared minus 2 minus root y squared dy. All right. How about shells? How did shells go for you? We're rotating around x equals 2, this region, and we want shells. So when we're doing shells, we draw something parallel to the axis of rotation. You can see that my radius is here, that this is x, that this is 2. So r is 2 minus x. Well, what about the height? Here's the height. Height is top minus bottom. The top is y equals x, and the bottom is y equals x squared. So I end up with 2 pi 2 minus x minus x squared dx. And there it is. I really do think that a hard washer can be an easy shell. Okay, so what if we now go around some negative stuff? How about we take our region, which goes here. Here's our region. And this is 1, 1. Now what if we rotate around x equals -1? I think I just heard some of you clucking. Ah! Go cluck. Stop! Okay, so if I'm doing disks or washers, then I am thinking about drawing something perpendicular to the axis of rotation. Here's my little r. And there's my big R. Now, little r is the distance from here to here, or right minus left. Well, that's x that goes with y equals x, and this is -1. So I could say x minus a minus 1. So x plus 1. But watch out, because this is a dy washer. And so I got to get rid of that x and replace it with some y stuff. Well, the y that goes with this x is y equals x. Oh, that's no problem. So there's little r. Big R? Well, big R is also an x value, and I do still want to say right minus left. Except in this situation, this x value isn't the one that goes to y equals x. It's the one that goes with this y equals x squared. Y equals x squared. And so x is the square root of y. So this is square root of y plus 1. And really it was square root of y minus a minus 1. So pi 0 to 1, again, we're integrating from 0 to 1. Sorry, we're integrating from 0 to 1. That's it. And we've got big R, square root of y plus 1 squared minus little r squared dy. Okay, and so what happens if instead of that we're doing shells? Shells around -1. Well, I'm going to draw something parallel. I'm going to draw something parallel to the axis of rotation and make that axis of rotation the center of my circle. This is the radius. The distance from here to here is called x, and the distance from here to here is 1. So radius is x plus 1. You could also get there by saying right minus left. X minus a minus 1. Same. That's my radius. Okay. These are shells though, so let's remember that because this is now dx. dy washer is a dx shell. We've got the radius is x plus 1. What about the height? Well, height is just top minus bottom. So that's going to be x minus x squared. So here we have 2 pi 0 to 1, because we're only integrating from here to here. We're only integrating the region, not over here. No. So integrating from 0 to 1, x plus 1, x squared, x minus x squared, dx. Ta-da! There you go. Okay, I did those. Now it's your turn. I know, it's great. These will be the last two for this video. I want to rotate about y equals -2. So will you show me the setups for rotating our region, disk or washer around y equals -2, and shell for y equals -2. Okay, pause the video, give it a try, come back when you're done. Hey, and look, if this is terribly frustrating for you, I mean, it could be very frustrating for everyone. I just want to say, you're not asking enough questions. Ask on GroupMe, okay? I mean, really, while you're suffering through this, I finished making the videos. I'm retired. I am literally just hanging out, resting. So, send a question. Ask Mr. Paz. Oh my God, you see him every day. I'm so jealous. All right. So, go pause that video, give this a try, come back when you're done. Okay, so let's see what this looks like. We have our region, we have our line, y equals -2. We're thinking about disks and washers, so we draw something perpendicular to that. And we've got this. Now, before I go further, see that little bit in there? That's the y value that goes to this curve. That y minus that -2. Y plus 2. Fabulous. Except this is a dx washer. So no y stuff here. I need what y is equal to. This y goes to the x squared. So we want x squared plus 2. That's our little r. Now what about our big R? Our big R actually goes all the way from here to here. And again, we could think about that as y minus a -2. This time, this y value goes to the linear equation y equals x. And so I end up with x plus 2. So my integral will be pi 0 to 1, big R. This one's big R. X plus 2 squared minus little r, which is x squared plus 2 squared dx. Wow. Some people forget that. Some people forget that. Try not to forget either of those things. Please be so kind. Okay. And what about shells? Our last one. Well, shells. So here's y equals -2. I draw something that is parallel to the axis of rotation. And that's what I'm looking at. So this distance is the radius. And that distance is the y value on the curve. So the y value on the curve. There. X, y. This y value minus this y value. I'm doing top minus bottom. Y minus a minus 2. And it gives me y plus 2. Okay, so that's fabulous for radius because this is a dy shell. Now what about height? Well, height is going to be right minus left. And I'm seeing these as x values. This is the x value that goes here, and this is the x value that goes with this curve. Well, we've been saying that this x value is square root of y, whereas this x value is y. So if I do right minus left, I get that height is square root of y minus y. So 2 pi, 0 to 1, radius is y plus 2, and height is square root of y minus y dy. All right. Yeah, and that's a lot, huh? How's your brain? Are you using an ace bandage to hold it all together? Ask more questions. I can't stress that enough. You'll be much happier if you practice this a lot and if you ask a lot of questions. And I look forward to seeing you in the next video. There are only a few videos left. You should enjoy them while you have them. Take care, everyone.